Hey, how's that intro? It's quite a thing. Lots of fun putting those things together. I hope I get better and better at it as I try it more often. Anyway, aloha, and thank you for watching my channel. I really appreciate it. Hopefully, I can earn your subscription today. Anyway, we are going to go over 3 separate capabilities within the Flex-VPN Lab, and I hope you guys are really interested in this topic because we're going to cover site-to-site using Flex-VPN. We're going to cover hub to spoke with multiple hubs, and then we're going to also cover spoke-to-spoke capabilities. So you'll be able to optimize the routes, assuming that the different branches can communicate with each other. So as long as they can communicate with each other and there isn't some kind of restriction outside of your control, you should be able to ping each other. If you're able to ping each other, that means that the vendor is not blocking your path. Or, it's possible they could be just only allowing tunnels to go through, and it wouldn't matter if you can ping. But anyway, this lab is going to assume that you don't have any restrictions. And if you do have restrictions, it's always best to work with your provider. So here's the lab. It's very similar to the ones you've done before. This one is specifically for FlexVPN with 2 hub routers and 2 branch routers. We have 4 different systems. We have 2 servers, server 1, server 2, user 1, user 2, user 1 on branch 1, and user 2 on branch 2. On a later lab, we will cover the fact that I have a CA server and a DNS server in here, and we'll make use of that by converting the lab from using pre-shared keys, which is what we're going to be doing today, to using digital certs. But for this lab, the 3 topics we're covering are site-to-site, hub-to-spoke, and then spoke-to-spoke as well. So let's get to it. I already started the lab because I know that this lab is, or already started the machines because I know that this particular video is going to be a fairly decent sized video. I believe that all the communication is going to be working. I've tested this lab quite a few times before ever making this video. So as long as it's working, here we go. I'll go ahead and stop this one and restart it. Hopefully that doesn't take too long. We'll go ahead and cover what we're going to set up here, and I'll start setting up the second one since this one's already up. So what we're going to do, we're going to set up the key ring. So this is the pre-shared key, and then we're going to use the proposal, the default proposal for smart defaults is what they're calling it for FlexVPN. I know with the previous versions I always delete the defaults, but in this case we'll work with the default profiles whenever possible just to shrink the amount of configuration we have to do. So everything that is here specifically for the second hub or data center, if you will, is going to be configured now. So right now we have nothing configured. or Flex-VPN or anything else for that matter. All we have is the basic configuration. Let's go ahead and set that up. Set up the pre-shared keys. Assuming that I don't do a lot of typos today, we might get through this lab. For the site-to-site, we're just going to do the specific IP address and not worry about multiple devices because, again, site-to-site. And we'll set up the profile. We're not going to have a lot on this particular profile because it's really designed for the two hubs or the two data centers that communicate with each other. So DC1 and DC2 using a private, let's say a site-to-site private connection circuit going between the two. So the domain I'll be using for this is test lab. There won't be a .com or anything in it. Just trying to shrink the amount of things I have to actually type. And we'll set up the authentication for local and remote, pre-shared keys, and let it know which key ring we're using for this. And then we just have to do the IPsec configurations. And we'll make it the most secure that I can think of at the moment. Settings. Unlike the previous labs I did, the weakest protocols, DES, MD5, etc. Here I'm going to use SHA-512 and AES 256, which is pretty darn good. And we'll go ahead and tell it the transform set that we're going to use, which is XF1 hub, and then the profile, which we called hub IKE profile. And let's go ahead and set up the tunnel, and then we're done on this router, and we still have to do the other one. Oh. Let's try that again. Remember, this is on gig 01, this interface, and we're assuming that there's a carrier in between. Well, not assuming, this is the scenario here. And so 01 is going to be the source interface, and then the destination is going to be the other router on gig G01. Go ahead and do Mtu Discovery, and of course encrypt it. Just to make sure that all the settings are in there in memory running, I'll go ahead and shut it and no shut and save. And let's take a look. Nothing should be up because we did not configure the other router. We were waiting for it to come up. So let's go ahead and configure this one. We'll do the key ring. share key. Set up the profile. And last time we told it that the remote is DC1, but this is DC1, we're going to DC2. Pull a qualified domain name, of course. And then let's specify that we are DC1.testlab. And again, fully qualified domain. Pre-shared key for both remote and local. And the key ring is flex keys. Now we can do the tunnel, or we can do the IPsec configurations. And now the tunnel. Setting up the source. Again, it's gig01. Destination is DC2 test lab. Oh, sorry. That will not resolve correctly because we're using the site-to-site. So let's finish this up. We have one hub. Shut it down. Bring it back up and see how it goes here. Okay, so now we have the routes. Let's take a look at the interfaces, and you can see that the tunnel is up. Let's go ahead and ping the other side, make sure we typed everything correctly. 32.2 should be the other side, and it does respond. If we look at the crypto IPsec, we should be able to see, yep, encryption, decryption. Everything is so far going well. Let's go ahead and set up the, okay, so the site-to-site obviously was very simple. We only had to do the initial settings. I'll go ahead and show you what that is. So right here we have the IPsec configurations. We'll just look at everything. So here we have the keyring for only one device, which is over there. The profile, the IKE version 2 profile. The IPsec configurations, and then of course the tunnel. If pretty much everything matches except for, of course, everything's reversed as far as the IP addresses are concerned. Now what we're going to do is we're going to set it up so we can support, we're going to lay out the groundwork so we can support the spoke routers. Because right now the site-to-site configuration is only part of it. So let's go ahead and get to that. We'll get started. We'll set it up with AAA. I'll go through that, why we're doing that in a second. We'll set up the pool. Now, as I work with FlexVPN Hub Bespoke, the more and more I work with it, the more I realize it's actually for the best if you use dynamic IP addresses defined by the hub. So each hub basically sets that information, and it really makes a huge difference later on when you're troubleshooting. All the features seem to work as expected, as long as you don't run into a bug. Yeah, what can you do? Bugs happen. I'm going to set up a authorization for different domains rather than different systems. So if you looked at the site to site, you could see that I was set up specifically for the hub router and for the DC2 lab, the whole name, the fully qualified domain name. Here, what I'm going to do is I'm going to allow you to have 100 branches, and as long as they have the domain name set up the way I expect it, it'll be able to be authorized. So let's go ahead and set the groundwork for that. We're going to do some authorization policies. And we'll say 10 meg branch. And the only thing we're going to do right now is just set the bandwidth to 10 megs. So in order to do that, I want it to be dynamic. So if we upgrade the branch's bandwidth, or for a different branch, whatever, we'll be allowed to dynamically know the bandwidth. Now, right now, of course, we're only using that for EIGRP, but that will be useful later on when we do the QoS version of this lab, which will be coming up soon. But in order to do that, you have to be able to do dynamic changes based on the authentication authorization of the branches. Now, I did leave something out because I was only thinking of the bandwidth, but we also, like I said, it prefers to give out the IP address. So let's go ahead and tell it to do that. And I'll go ahead and do that for the 25 meg as well. Assign the IP addresses and let the other system know to go to the interface on this router. Let's go ahead and set up the details, the actual dynamic attributes are called AAA attribute, and we called it 10 meg branch. And what we're going to do is we're going to set this attribute type, and it'd be good if I didn't add too many A's. Attribute type is going to be interface configuration. And right now, the only thing we are doing is changing the bandwidth. Later on, like I said, we'll do stuff like QoS, and some other parameters will be defined. But for the scope of this lab, that's it. Now let's go ahead and set up the rest of the hub. This is going to be used for the tunnel for the hub. And let's modify the keyring because we're going to use a different keyring or a different peer entry for the branches. So we'll call it branches. And we'll use the network here, right here. Let's say this was MPLS or RNS or something like that. The IP addresses are within this realm. And right now we're letting this guy control the 200.x addresses, but the tunnels for FlexVPN are going to be controlled by the hubs going through the transport layer, going through the MPLS. So we'll set up the pre-shared key, and now let's go ahead and set up the profile. We'll call this one spoke profile because it'll be handling all the different branches as well as any other shortcut router that we end up adding to this MPLS connection. So it doesn't necessarily have to be the company's brand. We could actually have security controls. We can do ACLs and have vendor routers out here and set things up using the same MPLS cloud. So we're going to set up the allowing the remote identification to be a fully qualified name, but we're only going to look at the domain. So we'll allow for 10 meg and we'll allow for 25 meg. And we'll have to identify ourselves, of course. And that's a local definition, and we'll call ourselves DC1 or Data Center 1. Authentication is still pre-shared key for both local and remote. Again, we will be changing that later on. And here's where it differs from the site to site. And what we're going to do is set up the authorization group of pre-shared keys, and we're going to use the Flex-VPN that we just configured a minute ago, and the domain mangler, the name mangler. And then we're going to set up a virtual template, which is the addition to the site that we didn't have before. Let's go ahead and set up IPsec specifically for the spoke, for the hub to support the spokes. So spoke. In fact, we'll call it PF1 spoke or XF1 spoke. X is in transfer, so that's the basis of my naming scheme there. I think it makes it easier if you have some kind of useful name when you're naming these things that you can easily remember what it was for. We're going to do SHA-512, and we have to use the transport mode for this. We'll set up the profile, call it PF1 spoke. And if I can get past the typos, XF1 spoke. And we're going to do the profile here now. So the last thing needed here is to set up the virtual template. So we're using the loopback address for the template, and we're making sure that the type of the template, the tunnel template, or the type of the template is a tunnel. Just in case you don't specify that, it's not going to be a tunnel. So the source is now, instead of gig 01, it is now gig 02. We're going to do auto Mtu Discovery and protect using the profile we just created. And here we're going to set up the next hop routing protocol just like we do on DMVPN. There is actually not much of a difference between the two, if any at all. That's the awesome thing about Flex-VPN. It's basically DMVPN, IPs, site to site, whatever you want. The whole point of why it's called Flex is because it's flexible, and it really is worth getting to know. Getting to know Flex-VPN, as it basically incorporates everything. I can't say enough about it. Let's go ahead and set up the, let's do one of the branches. Just so we can go straight to it. So this, as you can see, is a little bit smaller, less complicated than setting up the hub, but not much smaller, just enough. When we start allowing spoke to spoke, it will be fairly close to the same amount of configuration. So we'll set it up for new model straight away. And we'll set up a generic authorization policy. And we'll call this Flex like version 2 policy. And the only thing we're going to do is set the interface. Set up the keyring. And we'll call this Flex peers. The naming doesn't really matter. It's really just the IP address that you call it. And in case you're wondering, yeah, it's netmask. And you can really tell if you question yourself anytime, just hit question mark and you'll see either wildcard or mask. Let's go ahead and set up the profile, and we're calling this, assuming I can stop doing all these typos, profile, and we'll match DC1, because right now we're only setting up the tunnel for the data center 1. And we'll identify ourselves. This one in here, if you look over here, I said this is a 25 meg circuit. So we're going to follow that and make it a 25 meg circuit by calling it branch 25 meg. And we'll do the authentication, pre-shared key for both local and remote. And we'll set up the keyring. Now we're going to throw things off a little bit. Before you didn't have this. So we're going to start making use of AAA for defining which policy is going to be used to authorize. And it kind of allows you to individually configure which device, if you want, to be able to be authorized. In this case, we're just going to authorize it. But at some point we will change it, and you'll have to have an entry for everything. So here we're just saying, hey, no matter what, use this as the authorization policy for AAA. So we're really not doing anything unique here. We're just kind of showing how to do it, where before when you saw the site-to-site, I was only using the default, the smart defaults, or would that be smart default? Well, I'm just using the default. And now, this time, I'm showing you how you would do it without using the default. And then, of course, we want to do the virtual template 1. Sorry about that. We didn't need the virtual template, but we can leave that there. It doesn't really bother anything. Let's go ahead and set up the IPsec, and we'll call this XF1 Flex. AES 256, and we'll use SHA again. SHA 512, transport mode. And here we want to set up the profile, and we'll call this PF1 Flex, and make use of the transform set, which we called XF1 Flex. Did we not? We did lowercase. I'm going to delete that because I actually want it uppercase. Let's try that again. So many typos today. Let's try this again. XF1 Flex, and then the spoke Ike profile. Now we'll set up the tunnel 200. This is going to be specific to communicating with the first data center. That will always be our primary and our mine, and so we'll set that up first. So we'll shut down the interface so it doesn't take any of the attributes until we're done. We're going to do negotiated IP addresses. Remember, on the hub we do the IP pool command, and we want to make use of that. And we'll set, in this case, the bandwidth is going to be 25,000, and source is 00. So this is, the branches are 00 going out towards the MPLS cloud. This destination is DC1 test lab, and we'll do auto discovery for the MTU, and go ahead and set up the protection profile, which we called PF1 Flex. Go ahead and set up next up routing network ID of 1, and we'll turn the port back on. If everything went well, the connection should be up now. Let's take a look. It is not. So let's see what went wrong here. If we look at the profile, we are going to identify ourselves as branch 1, branch 25 meg, virtual template 1, which we don't have. We're using Flex Ike version 2 policy. That looks correct. Let's go ahead and see what it says in debug. Not found. So oh, I didn't I didn't put the pre-shared key in there. I thought I did. Guess not. And the key ring is branch keys. Go ahead and force that so we can see any debug. And it looks good. Okay. We'll remove any debug, and let's make sure we can ping. As always, you want to ping every step of the way. That way, if there's anything that you did wrong, oh, look at that. Tunnel's still down. We didn't have an error on this side, so that's a big indicator for us. Let's see what is going on here. We'll force it instead of waiting for it. Okay, once it settles down enough for us to be able to read it, it's going way too fast for me to read it. But once it settles down, I'll take a look at the output and we'll see what's going on. Okay, I can see the error already. Okay, you can see right here, branch 25 is what's used. It did accept that. Accept the interface. I thought I saw the problem, but really the problem is the pool. So let's see if the pool is there. Which is not. Another typo. Where'd it go? Pool. So this is called Flex Pool. And we'll do 2 through 254. Now let's go ahead and force it. And there we go. We now have 2112. We should be able to ping 21110.111, and we can. Now, if I remember right, we haven't done the second data center yet. So let's go ahead and look at that and make sure I'm correct. Yeah, so we haven't set anything up to support the spokes. We've only set up the hub. So let's go ahead and set that up. And now the name mangler, which is just telling it to use the domain name only and not the whole full qualified domain information. Authorization, branch 10 meg. Setting up the IP address range, and then allowing it to define the loopback address as the next hop. Oops, this one is 25 meg. Okay. Go ahead and I guess we could do this, but we'll just set the interface on that. In fact, I don't think I did that over here, so I'm going to do it over here just to make sure. I kept 2 authorization policies. I'm pretty sure I didn't set it up, so let's go ahead and set that up. I don't expect to, but just in case. And then we'll set up the AAA attribute information. Interface config. Again, this is more dynamic, but it's also how you bypass the whole requirement for. Let's say you find a tweak that you need to do. You have 100 branches in this FlexVPN configuration. You're not going to be able to modify that template unless you are do it during a maintenance window, because everything is going to have to be shut off. You're going to have to turn off all the tunnels going to this router. So in some situations, this knowing how to do this can actually save you from having to wait until you find a maintenance time. You can just do this change on the fly. Really good information to know when you're handling a large group of devices. So this wasn't really that useful for the lab, but I think for your own personal knowledge, I believe this is really important to know. We'll go ahead and set up the loopback address. Remember, the other one is 10.1.1.1, right? And this one's going to be 10.2.1.1. And did I set up the pool? I bet I did, but I have a feeling it wasn't set up for this router, which should be 10.2. It should be 10.1. So I'll correct that now. And there you go. go ahead and set up the keyring, or modify the keyring, to allow the branches. So we'll call it pure branches. Again, that's just an arbitrary name. You can call it whatever you want. And the pre-shared key is branch keys. Okay, remember we're going to do the domain name and not the whole fully qualified domain. So we'll set that up with the word domain. Notice I highlight it in green just so there is no accidents. We're going to do 10 meg for this lab purposes, 25 meg, and then anything that has the same domain. We are DC2, and we'll authenticate for both local and remote. It's going to be pre-shared keys, and set up the key ring, which is flex keys, and using AAA, we are going to use the name Mangler for the authorization profiles. Set up IPsec. And this one will be ESP. Actually, I believe I'm using the same for all of them. But it's a good, baseline. 512 HMAC. And we'll go into transport mode. And let's set up the profile. Tell it which transform set to use. And we're going to use spoke. And then the profile, the IKE version 2 profile is spoke IKE profile. Now we can do the virtual template, assuming I can spell it correctly. And this is type tunnel. Always a good idea not to forget putting that word there. It's really important. Now remember, we don't have a destination on here because this is a hub. So you would only put the destination when you're on the branches or if you're doing site to site. But if you're the hub, you're relying on the profile to determine what the destination is. So you're only receiving. We'll go ahead and do auto discovery for the MTU. Really important when you have encapsulation involved. I would just do it on any type of tunnel. I mean. And we're going to set up the next hop routing information, which is network ID 1, and we'll set up the redirect, timeout, and the shortcut. And we're done. Now that we've done that, let's go ahead and set up this branch that we already set up to go to this data center. Now let's set it up to go to this one as the secondary. So just to show you what we have, we have it set up only to go to one data center. And we also only have one tunnel set up. So we received this IP address from data center 1. We're going to set up another tunnel, and we should have a 10.2.1.2 if we're the first one, and if we don't run into any errors. Luckily that's dynamic. It doesn't really matter if we get something different. So let's go ahead and set up the changes. Crypto profile. And really, in there, all we are is making it so we accept the second data center. And then we'll set up the new tunnel. Go ahead and shut it down. And bandwidth is 10,000 on this one, where the other one was 20. Oh wait, this one's 25,000 because we're still on branch 1. Tunnel source is 00 because this is the branch. Destination is UZ2 test lab. We're going to do auto discovery for MTU and then set up the profile for protection. And we are done. If we did everything right and didn't have any typos in either DC2 or the branch, we should see the tunnel up, which we do. Let's make sure we already checked to see if we can ping that. Now let's see if we can ping DC2. Yes, we can. Nice. Let's go ahead and set that up for this router. So we have all 4 routers configured before we move on to the next step. I'm pretty sure I have not configured anything on here. Yep, brand new. Okay. I'm going to set up the authorization. This one is Flex version 2 policy. Again, all we're setting up is the next hop. Now let's go ahead and set up the profile, or the keyring. Pre-shared key is called branch keys. And now the profile. And we're calling this spoke profile, if I remember right. Yes. And I'm expecting data center 1, because I like to do one at a time. It makes it a lot easier to troubleshoot instead of trying to do a whole bunch at the same time. Local, and we are branch 2, and this time we are 10 meg. And remote and local is pre-shared key. Keyring is flex keys. And here we'll do the authorization using AAA, local AAA, for authorization. Of course, as I said before, this is really just authorizing anything that hits it, pretty much, as long as it matches, at this point, DC1.testlab. We'll go ahead and set up IPsec. XF1 flex. And I'm getting a little too quick on hitting enter here. And we'll set up the profile, which is called PF1, and let it know what to use. So, spoke Ike profile. And let's set up the tunnel. source is gig00, and the destination is DC1. We'll set up auto Mtu Discovery, and then the protection, which we call PF1 Flex. And put up next hop routing. Network ID is 1, and then we'll go ahead and turn the interface on. And as long as I did everything right, didn't do any typos, the interface should be up, which it's down. So, what did I mistype? The good thing is I'm getting plenty of debugging time here with you guys. I'll go ahead and enforce that. And let's see what kind of errors we have here. And when this settles down, once again, I'll be able to see what it is. Come on. It's just moving too fast for me. Ah, good, good. Let's see what the problem is. Okay, let me see. Did I forget to type domain? It kind of looks like I did. Yeah. Okay. Oh no. This is the DC1. Let's see what the error was. Okay, so got the key and accepted it. We're using the default proposal. Look, my profile looks correct. It almost looks like the problem is on the hub. Okay, branch 10 meg test lab. Let's take a look at this. Oh, it's a pool issue again, which means when I did the authorization policy for 10 meg, I must have typed it wrong. Let's see what we have here. I didn't type it at all. There you go. Okay, so I left two things out of there. So let's go ahead and add those in. And this was left out, and so was setting the interface. So now, if I shut that down and bring it back up, hopefully the interface just works. And there you go. Okay, but just like the other one, we need to set it up for the second one. Hopefully I didn't make the same mistake on there. We will find out. Exciting stuff. It's like watching grass grow, but a little bit better, yeah? And we'll set up tunnel 201. Assuming I can type it correctly. We'll shut it down. Negotiated IP address. This is a 10 meg circuit. Gig 00 is the source. And destination is DZ2. Mtu Discovery. PR. And we'll set up the top routing stuff. We'll see if I made the same errors. And 2, 1, 1, yes. Okay. All right, well, we managed to get that one. And let's go ahead and set up the dynamic routing. We're going to use EIGRP. Now, remember in this particular lab, the statement is that the vendor manages their own routing table and they control how one router reaches the other. In our agreement with that vendor, they're allowing every router to communicate with each other in this, but we have agreed that we will not advertise any of our internal routes into this MPLS cloud. So you have two different EIGRPs in this case, or it could be BGP, whatever. For me, it is much more convenient to do EIGRP, but I'll show you what I have. As you can see, as agreed, only the MPLS cloud is on here. So we're going to use EIGRP, and it's going to be 50. And by default, this particular iOS version of hardware is going to do no auto summary, so I don't have to do that. And actually, following that whole parameter, I should make the interface going to MPLS as passive. So in no way can they come back to us and say, hey, we told you not to put any routing on here. So on 02, we're not going to advertise ERGRP 50. Go to passive 02. I'll do the same for this one. So passive GI02 and we'll advertise 10.0.0.0. Actually, when I think about it, we do want to, if something happens, 10.0 should cover this particular situation, but who knows? Maybe we wanted to have the 172.16 addresses going across as well. At the moment, I can't think of why I would want to do that, but you never know. But actually, if we want the neighborship to come up right now, we're going to have to. So let's go ahead and put that in. 172.16.32.0. Because remember, 32 is the tunnel we have between the two data centers. So. And there you go, neighborship is up. Go ahead and do the two routers. And we're going to block 00. Now when you look at this, we can see that on ERGRP 50, we have the following network segments being advertised, and maybe it's cleaner just to do this. There you go. These are the networks being advertised through that segment, through that ERGRP and 50. Unfortunately, when we do a trace route, and let's say I want to trace route to here, it's 1099.35.100, right? It's 3 hops. But when I'm going here, you're going to see that it actually is a little bit more. So that's 112.2.100. And there you have an additional hop. Why is that? I mean, they're right next to each other. Well, right now, we're forced, when going here, we're forced to go to the hub to go back to this router. So that's why we have an extra hop. We will address that with the next section, number 8, where we will optimize the routes. All right, so here we have the baseline for user 1. Let's go ahead and create a baseline for user 2. Assuming I don't mistyped the username password, which is the easiest in the world. Cisco, come on. And I want to do a trace route to 10, let's say 135.100. And then I also want to do 112. And this one, the user one is 1.100. So as you can see, it's 3 going to the data center, and then it's 4 going to the other branch. Let's go ahead and fix that. We'll start off with this one. We have tunnel 200 and 201. And let's take the steps to again, use the domain name instead of the individual device name. Make it a little bit easier and less of a administrative nightmare. We'll do it per domain. And the only thing we're doing here is setting the interface as the next hub. Unlike the hub where we did the flex pool and we did the AAA attributes, although in a later time when we do QoS, we will be doing more, we'll get more and more involved in the AAA attributes. But for now, all we're doing is setting the interface. And we'll do that for 25 meg. And we'll also do that for just plain test lab. Okay, we'll remove the previous authorization policy, which we call Flex IP2 policy. And we'll modify the profile to reflect that change. Oh, my caps lock got hit. Let's try that again. We'll match the domain first, and then the test lab, and remove the previous one. So FTDN DC1 and DC2. Remember, we're doing it strictly on the domain name now. And now we'll add, because this wasn't in there before, the AAA authorization. And virtual template 1 is what we're going to use now. Let's go ahead and set up tunnel 200, shut it down, set up the shortcut information. And remember, always set up the tunnel type as tunnel. I mean the template type as tunnel. This is branch 1, so 25 meg circuit. And we're setting up for the primary data center. We're setting up the shortcut, which is absolutely needed. tunnel. So as you can see, we have now tunnel 200 and 201, which we had, but now we have the virtual template, which will always be down. When we do a shortcut between the two branches, you'll see a virtual access just like you do with the hub. So the hub, you always will see that. So virtual access 1, virtual access 2. Well, what's that for? Well, there's a couple of easy ways to figure out which branch that is going to. You can do the show IP route and look at only the access 1. Oh, I'll spell it out. Access 1 or access 2, and that will tell you, of course, what segments are being advertised. Another way would have been to look at the neighborships, and there's several different ways to figure out, well, which one is for which. I almost always look at the configurations of the device and what have you, but to know which one it truly is, outside of looking at the sessions, which is another way, right? Because it tells you the virtual access 2 or virtual access 1 is going to this router. So if you know the IP addresses by heart, that works out, right? There's just so many different ways to find out what it is. Here's another one, right? And it tells you the name right there. So when you use the brief command on session, it's either going to be show IP route or neighborship or session brief. And session brief by far looks like the easiest, unless you have different types, which will be on a later lab. But for now, I just want to show that. So let's go ahead and configure the second branch router, and then we can test it. So I believe we already did the baseline. Let's see. And we'll make the changes, which I'm pretty sure we haven't done on this branch yet. Let me double check. Yep, definitely not. And we're just going to set the interface, that's it. Route. Gotta remember, not add that extra R. You configure so many routers and switches, or in this case routers, you have a tendency of doing a lot more configurations with the R at the end. Let's go ahead and add 25 meg and test lab. Okay, we'll remove the previous one. Called Flex Ike version 2 policy. Because it's no longer needed. We'll add the domain matches. Try to get through this as fast as possible. remove the two data centers. And add AAA authorization capabilities to this. So we're more dynamic than we were before. And of course the virtual template. This is branch 2, so it is 10 meg. We'll set up a shortcut. Source 00, destination DC1, the auto Mtu Discovery. If I did everything right, it should be coming up again. And yes. Okay, just to make sure, 111, yep, 10211, we're good. Now, we are done with configuration, so let's go ahead and do the fun part. We'll bring up the shortcut. It is a temporary shortcut. It's not up permanently. It's only brought up when it's needed with our current configuration. So we'll activate it and we'll watch it happen. Okay, so now we have the neighborship, we have the interface. Let's see if the next hop routing has been modified. And yes, it has. However, that's only half the battle. We also need to make sure that it works this way as well. So you see here, the interface did come up, but you're going to see it may or may not match. Oh, it does. Okay, perfect. Sometimes it doesn't. It's a timing thing, of course. And if you look at the next hop information, you can see it's all here. Now, a lot of times there's so much information, I only want to look at the branch of concern. So is this branch have a shortcut to that branch, right? So what would that be? You should see a percent sign for any route that was overridden. And virtual access 1 is it. So let's look at this. You see it's from this router to that router, and if we look at the details, you'll see that 10.1.12.2 is going directly through access 1, which is why it's bypassing the tunnel to the domain controllers. again, make sure it's working on both sides and nice and quick, just the way we like it. Now, of course, all the troubleshooting tools are available to you that you have for any other VPN, uh, and then some. So because of the fact that we're using Flex-VPN, we have a little bit more available to us, but these two have been the most invaluable commands to me out of anything else. If, if I ever have a question why a tunnel is not coming up, it's usually going to be IKE version 2. Either I mistyped a pre-share key, I didn't enter in an authorization correctly, the IP address pool, right? There's so many different, the keys, the addresses, all that stuff is going to come out when you do these two debug commands. And it's always best to shut down a tunnel in question, bring it back up so you don't have to wait for when it attempts. Anyway, I hope you learned something from this lab. I hope it helps you get much, much deeper than you would have otherwise without these type of resources. Cisco CML is an awesome product, and but there, again, just like I said before, there's EVNG. You can just do most of this stuff on ESX directly, put together your lab. You're going to be able to make use of the scripts, even if you don't have, even if you do hardware, and you can't use my scripts to do the work for you. You can always look at how they pre-configure the lab, so you don't have to figure out what the setup is from the beginning. And mahalo for watching, and aloha. Thank you.